Yeah, we're going to be taking it from where it is now all the way to $10 billion
Exactly.
market
That's
cap
the Ponzi
this
scheme we can
cycle.
set
Yeah,
up.
next. Yep. Yeah, as many price dependencies as possible. We want to make sure that we're collateralizing everything with TRB and just integrate it to the system everywhere we possibly can.
Yes, I know Brenda and the team are listening in, so we're just joking.
Just having a heart
Yes.
attack. Cool, man. Well, yeah, I'm really glad to get to do this space with you and talk about Tellor, your tokenomics, and give a bit of a background. So we knew each other through a mutual friend who was building some things on Tellor, and Tellor came up on my radar maybe like 4 years ago. It's pretty cool that this is the first space in this series that I want to do on spotlighting protocols. And it's fitting that Tellor is going to be this first one, because Tellor was the first token that I modeled. And I was looking at the TRB payments in the ecosystem in 2019 or 2020 to try to figure out like what the intrinsic value of TRB was. So I'm excited about that, about Tellor being the first one for this reason. I'm also excited because Tellor is one of these protocols that I would say is like, I'm working on the terminology, but like an immortal protocol. It's a hyperstructure. Like you're building in your final form, like the V1 is there. It just exists forever and anybody can use it. So it's always available, and there's no risk of like rugging people with an upgradable contract or something like that would compromise the protocol. So you guys are really focused on censorship resistance, and these are the kind of protocols that I want to highlight. So that's a little bit of a background on this space, but maybe you can introduce yourself, and then we can talk about what Tellor is.
Yeah, sure. I mean, that kind of works as a great introduction. But so I'm Nick, one of the founders of Tellor, and yeah, we've been kind of right before Tellor. I was building a derivatives protocol, and this was in 2018, and you quickly realize that you need an oracle. So how do you get the price of an underlying asset, whether it's Bitcoin, Ethereum, whatever you want to create? And back then, this was pre-Chainlink even, so we decided we wanted to create our own. Wanted to make an actual censorship resistant oracle, and we kind of jumped into the path of Tellor. And yeah, the first version of Tellor we had launched in mid 2019, and then we've done a couple new versions since then. Kind of been on this last one for a few years now, and it's working pretty cool. Happy to explain it.
That's awesome. And so you guys are an Oracle protocol. You're a censorship-resistant Oracle protocol, which I want to distinguish from the non-censorship-resistant variety, the potentially censorship-loving variety. And I think that's really important to highlight. But Tellor is an Oracle protocol. So maybe you could talk about like, what are oracles? Why are they important?
Yeah, so oracles in general are just ways to get off-chain information. So just the way that a blockchain works is, you have these smart contracts and you can write them, but everything sort of has to be self-contained within transactions. So you couldn't say like in this smart contract, oh, we're going to call the Coinbase API to go fetch the price of ETH. The reason that you can't do that is because like you're supposed to be able to replay these for all of time. So, if somebody in a year went and replayed all of these transactions, from the Genesis block in Ethereum, and then it went and called the Coinbase API, it would probably get a different answer than the one it got at that time. So that's a no-go. You can't do that, because then you wouldn't be able to verify the whole state of the chain in a trustless manner, which is the goal. So everything has to be sort of put into a transaction, or basically an external party has to input off-chain information as the input in a transaction. And this is the Oracle problem. It's how do you do that in a trustless manner? Obviously, like if you wanted, say, as we were doing a derivatives protocol, like let's say you and I wanted to bet on the price of Bitcoin. You think the price of Bitcoin is going to go up. I think it's going to go down. We can lock Ethereum into a smart contract. And then the problem is who gets to say what the price of Bitcoin is? Obviously, we don't want one of us to do it, because we have we'd probably lie and we would win. We could do, the classic, the easy Oracle example would be a single party Oracle would be like, okay, well, Brenda's here in the chat. We both agree she's a neutral third party. We'll let her be the Oracle. And that would work as long as you trust her. But if she died, or if she, if she wanted to be malicious, or we could go bribe her, it would not work. Same with, the next step would be, okay, what's a multi-sig? So, you could have, we're going to have Brenda, Dan, and Eric there. 2 out of 3 get a vote on it. And that's kind of where, that's like where the state of oracles has paused in a lot of ways. Most oracles out there would just sort of be this multi-sig. You whitelist a bunch of trusted parties and they get to put the price on chain. That doesn't necessarily work all that great. Just, it's not necessarily what we're building for here as far as censorship resistance goes.
Yeah, exactly. It's like all of those solutions are not really censorship resistant, and they still require trust in whoever you're appointing as part of that multi-sig or whatever scheme you've devised. And I think one of the things that I really like about Tellor's protocol is that it's not just like trustless; it's cryptographically secure, or crypto-economically secured. So there are economic incentives. I'm sure we'll get to these. I don't want to get to them quite yet, but the idea of a censorship resistant oracle is that you will have some economic incentives in place to guarantee that that data is accurate, maybe up to a certain threshold amount. So, and that's what Tellor works.
Yeah, I can explain it really quick, just how Tellor works. This is the idea of crypto economic security. Like with Bitcoin, it's proof of work. With Ethereum, it's proof of stake. It's not that it's like you have to trust anybody. It's like you just trust that, listen, these validators have a whole bunch of money locked up. They're not going to be dishonest because they would lose a whole bunch of money. That's kind of the basics of what crypto economic security is. And in the same way, we wanted to build something like that with Tellor. So the way that Tellor works is you grab our token, TRB, and you stake it, and then you're allowed to become a reporter. Then anybody else, they can come along and they can tip. So they would pay, like in TRB usually, say 1 TRB, and they would say, hey, can you put the price of Bitcoin on chain? And then all of those people who are staked reporters would then race to go throw the price of Bitcoin on for that reward. It's very, very competitive. Let's say you're the reporter, you throw it on chain. You say the price of Bitcoin is, I don't know, what is it now, like $40,000? And then
42.5.
Wow, yeah, it's coming up. But you say that it's a correct price, and then anybody can use it as soon as it's put on chain. The problem is you don't want to use it right on chain, so it's an optimistic oracle. So what that means is you would wait for it to see if anyone disputes it. So you would hopefully be checking it yourself for your protocol. The other validators are checking to see if they can slash you. But anybody can submit a dispute. So let's say rather than 42.5, you said the price of Bitcoin is $10 million because you want to win our bet. Somebody would come along and they take 10% of the stake amount and they dispute you with it. So they would say, hey, he lied. He should actually be slashed. What then happens is your stake and that dispute fee go and get locked into an escrow contract, and the Tellor community, basically the token holders, the users, and the reporters, they vote on whether or not you should get slashed. So it's a 2-day long vote, and if you were honest, you would get the fee. If you were dishonest, the guy who disputed you gets your stake. And it's completely permissionless, and that's the basics of how Tellor works.
And so you mentioned there are a couple of directions that maybe we could go with this, but you mentioned that Tellor is an optimistic oracle solution. Do you want to dig into that really quickly? Why is it important not to use the spot price of an oracle?
Well, the spot price is different as far as spot price versus optimistic oracle are 2 kind of different concepts. We're optimistic in the sense that, like, as soon as the value is put on chain, like, you want to wait for those disputes and check them.
Right. Yeah, like spot price is not the right term. What I mean is the immediate price that is given by the present oracle. Why would you want to wait?
Yeah, so you would want to wait just to do like a sanity check on it. We don't have too many disputes in our system, but they have happened occasionally, and you want to make sure that it's a good value, and if it should be disputed, somebody comes in and disputes it. Obviously, they're losing a lot of money, so there's not really any incentive for them to do that. But yeah, that's sort of what the optimistic means. Whereas, if you look at like a chain link or a pith where, they just have a trusted group of signers, it's not optimistic in any way. You just, as soon as they sign it, you consume it in your protocol. You would just assume that it's a good value, which is dangerous in many ways.
Right. I mean, it comes down to in those systems that use that type of oracle, it's that you're trusting that the group of people are, the correct people to be providing that price, and that they're always going to provide an accurate price or piece of data. Versus in Tellor, you're counting on the economic incentives, which in some senses accrue over time through the provision of the same piece of data persistently, or like a relatively close piece of data in the case of price data that you're feeding in over a period of 30 minutes or an hour or several days, so that you have like multiple blocks worth of incentives going toward the validation that a particular piece of data is correct.
For sure. And it's trustless in the sense like anybody can do it. So like you can even, if it's your protocol, you can run some dispute, we have what are called like disputable value monitors. Like you can run it and check for disputes to see if your protocol, needs to be protected with some disputes. Or you can even become a validator and report too. Similar like with Ethereum, anybody can become a validator. It's completely trustless. So big difference there versus, the whitelisted parties where more of the bigger risk with, like the risk of like a chain link or a pith or Maker's Oracle. It's not necessarily that they're going to be malicious and do that. They have too much token value riding on it. They'll probably just like have a software bug and go offline, and then you're really out of luck in a lot of cases. And that's that liveness guarantee and that you can do it yourself. It's a big deal.
Yeah, I mean, I'm hearing a couple things that I want to highlight. Like you just said, liveness, so that there's a guarantee that somebody will be providing the data, and there's a crypto economic guarantee that that data will be accurate because there's a financial incentive that anyone can take part in. So it's permissionless as well. There's like these distinct features that add up all to censorship resistance and um, make Tellor what it is, the unique Oracle solution that is the most censorship resistant and trustless Oracle. And I think for context for people listening, you might not want to say it, but I don't mind saying it, which is that I think a lot of the other Oracle solutions are like I want to highlight they're whitelisting specific groups of people, and they're saying this is a reasonable. Coinbase, yeah, they're pretty good for spot price of Bitcoin. Like we'll use Coinbase, and we'll get Coinbase and Binance and whoever else. And I'm not sure exactly how some of these protocols work under the hood, but I have talked to their members, and they've told me straight up. They're like, yeah, well, for this piece of data, we just pick who we think is going to be best at providing that. And that seems like maybe a there may be good trust assumptions being made there in terms of like the quality of data providers, but the first problem is that that is a trusted third party, and the second problem is that it's not the only the maliciousness is not the only concern. I think there's also the possibility of coercion, where you could, as a state actor, for example, if you really wanted to disrupt a certain protocol that was dependent on an oracle like Chainlink, you could identify the people that are providing that price and then go to them and say, "Hey, we need you to fudge this number." So it's not just the the guarantee that they're not malicious. There are other concerns there. So that was just one thing I wanted to bring up.
Yeah, I mean, I think there's a whole bunch of pieces there too. Obviously the regulatory capture piece would come up. But I would also say it's very interesting comparing like nowadays, now I actually don't even think they hide the fact that it's whitelisted parties. Like you would hear, back in 2018 when Chainlink would launch and early on, like you would have to at least feign decentralization. Like this was something that you needed to do in order to be taken seriously as a group. But nowadays, it's more, Pith is just very honest. These are financial actors. They're very trusted in the space. We'll give you all their names. Like we whitelist them in our protocol, and they provide prices. API 3 does the same thing, and it's just more like it's decentralized in the sense that a multi-sig is decentralized because it has multiple people. But that's sort of what they're going for, and they don't hide from it anymore. So the other piece that you were talking about too, whenever it's, oh, how can they attack your protocol? They be bribed and provide bad prices. I think maybe they might do that. I think some of the bigger issues too, like whenever you look at like, especially one of my bigger concerns with Pith, so it's the high frequency trading firms that are sort of providing data. So you would have whether it's Jump or Wintermute, and they would be providing prices for your DeFi app. The question is how do you know they're not front running you? They would obviously see the price that they're going to put on chain, and it's going to affect your protocol. There's very little protection from them front running you, and I think as a space we sort of get front run enough as it is. So just being really careful. Some people are working on this is called like the Oracle extractable value. What can they get? Anytime you have a whitelisted protocol, it's going to be you're probably going to have a bad time, or you're really going to need to design a protocol that can't be exploited in that way.
So Oracle extractable value through front running, because the Oracle is the person providing that price, and right before they provide it, they could potentially trade against you.
Yeah, well, I mean, there's two. So like, like obviously in like, depending on what protocol you're talking about, like if it's for a DEX, obviously they could trade against you if they know which way the price is going to go. But if it's like if there's liquidations on the line, they could, if they're the people that are allowed to push the data on chain, they could sort of take all the liquidation fees, and that would be, not fair for other people who are actually monitoring it, and it would lead to sort of a degradation of your protocol, as nobody else would even be watching for liquidations.
So there are multiple ways that the Oracle, as the person who's providing the price, can take advantage of other groups of users in the protocol.
Yeah, for sure. I mean, the Oracle kind of controls your protocol in a lot of ways. It's just a giant, it's one of the key components. Like if you're, I think other people have said it too, like you're only as decentralized as your least decentralized point. So, if you slap a multi-sig in the middle as your Oracle, it does not matter how decentralized any other piece is. This is just, you have a trust assumption relying on its multi-sig, and you should probably stop doing that.
Yeah, so I love that idea that you're only as decentralized as your least decentralized component. So how does Tellor solve for Oracle extractable value? Like what is the proper implementation of the Tellor protocol look like, and how does that solve for Oracle extractable value?
Yeah, I mean, we don't necessarily solve for it in any sense that we sort of have it just marketized in a lot of ways, that if it's open and anybody can do it, it's a little bit less of a problem in the sense that at least it's more democratic. Other people are working on, you can have auction mechanisms underneath for auctioning it off, but that's still really, really hard. To us, it's similar to like, how do you solve the MEV problem? It's, it's A, designing your protocols so there's less of it. And then B, just making sure that anybody can sort of participate in the network and compete on it, and hopefully it will drive that profit down to zero as you do so.
Yeah. I mean, that's kind of where I was going. It's like the openness and permissionless participation in the Oracle protocol tends to create those competitive forces that minimize the amount of value that's extractable by any one person, because everybody's competing to extract the least amount, so that they'll be picked. Like that's kind of what the market does when you have this environment of competition. And the openness that provides that censorship resistance that Tellor does through the protocol. So so my next question, is kind of related. It's like, what are the common challenges? We've talked about like the challenges um, of oracles broadly, which includes censorship resistant oracles and the whitelisting variety of oracles. But what are the unique challenges of censorship resistant oracle protocols? Like, what challenges did you encounter in designing Tellor?
I mean, the biggest problems that you're going to face anytime you're an oracle is just how do you overcome, how do you actually get used? Like obviously, like you can create a system that works and is beautiful and is crypto economically secure, but like if it doesn't sort of fit where the users are at and what they're doing, it's hard to get adoption. And this is where sort of we find ourselves in a lot of ways. You have protocols, and what they're building is they assume centralized oracles. Like right now, whenever people are building out lending protocols, building out stable coins, they're like, how can we get an oracle that is really, really fast and really, really cheap? And that's what they want, that they assume that it's secure, and they just want it really fast and really cheap, because obviously if it's really fast, what they want is they need to know the exact price of an underlying asset, which is sort of a meaningless thing. Like it's such a hard, nuanced thing that most people just abstract it away. But yeah, they need to know like the underlying price at an exact moment in time, which markets don't even know that. Like markets can differ, so wanting to know it right then is really hard. And then conversely, they want it really cheap. So like, if Tellor is slightly more expensive because you're paying a network of people versus paying a single party who's doing it off chain, it's it tends to make you less attractive. Or or the harder part especially is competing with protocols whenever they subsidize their oracle feeds using a token, and that makes it really, really hard to compete. So
Yeah, I mean, I'm seeing maybe like and I might be biased here because I like to see trilemmas and think of things in threes and solving for those kinds of things. But I'm kind of seeing a trilemma here. Tell me if you think of it this way as well. But like users, the devs that are employing Oracle protocols are looking for fast, cheap, and accurate. So maybe there's a trade-off between those three things.
for sure, yeah, no, I mean, even cheap, you could trade in security. It's like, yeah, because like the biggest piece, like like whenever it comes down to, especially price feeds, whether it's price feeds or, by the way, oracles can be used for other things, cross-chain information, prediction markets, weather data, basically anything. But there's always this trade-off as far as like, how do you come to consensus on what the truth is around something, and how do you know it? Like prices are really an easy one to talk about, because if you're doing like an ETH US dollar price, and you want to price every 1 second in your protocol, there's some challenges there. It's like, well, then you have to pay gas every second, which is crazy expensive. And then B, well, what happens when the price changes? So if you have ETH US dollar on Coinbase, on Binance, on Uniswap, and all of a sudden they all start diverging. One goes up and one goes down, and one stays the same. Well, what's the price? What price do you want in your protocol? It's not clear to the market yet which one. You can take a median. Is that right? Maybe. So having discussions with projects around like, okay, well, what sort of outlier detection do you want in this? If the price does flash up 50% in 1 second and then dips back down, in the next second, do you want that price reported to your project? Maybe. Most likely not. But like if you're just reading an API from Coinbase and it printed that price and you're pulling it into your protocol, you would get that protocol and you would probably liquidate a whole bunch of people. So maybe you don't want it, and you just have to think about like what are the various ways to go about it. And like if you do have a slower price, you're just going to need to probably build in more collateral and build in a little bit bigger of a buffer, which people, and then it goes into like now we're converging on like the stablecoin trilemma of like, the basics, like how much do you need to over collateralize system by to make sure that the collateral doesn't liquidate you. it's
Right.
super hard, and these are kind of unsolved problems that people are just playing around with the trade-offs and seeing what users like.
Yeah, I mean, I would reduce it even further and generalize it to the tokenomics trilemma. So there's a trade-off between utility, the protocols, the value the protocol is providing to users, the value capture, so that corresponds to the investors, right? And then the economic security of the protocol itself. So you've got the three groups of stakeholders: users, investors, and developers. And there are going to be trade-offs in the protocol anytime you're optimizing for one of these groups or one of the principles of tokenomics. So in the Oracle problem, I see it. The problem you're describing sounds a lot to me like you're increasing the costs to the end user in order to subsidize the security of the protocol. Because if you're making the Oracle, if you're requiring either more data points provided over time or more stake by the Oracle to ensure their alignment, then you're going to make it more capitally intense, which is going to cost users more in the long run.
Uh, yeah,
So in that way,
I
it's
mean,
a
I guess it works that way.
I'm just reducing. Yeah. So this is how I think of it. Maybe not how you think of it, but I do see a trade-off between like the end user experience, basically, with the cost to or the capital intensity, right? It's like if it's more secure overall, then it's uh, all else equal, it's going to cost the users more to use it.
Yeah, for sure. I mean, this is like, um, if Ethereum transaction fees are really, really high, it's going to be a more secure network because, miners are getting paid a whole lot more. You're going to have a whole lot more validators there and a whole lot more people running the nodes. And it's going to look like a more secure network. Whereas if fees are crazy, crazy low and, you know, they can't afford to subsidize themselves, then validators go away. And the same thing sort of works with Tellor. The more people that are using it, the more people that are, paying money into the system to secure it, then the more sort of eyes you get on, the more people are buying TRB, and the stake sort of goes up in a crypto economic sense underlying the protocol.
Right. And so I want to talk about a way that I think you've solved this, and it's a really cool mechanism that you've got. I think we've been talking about this a little bit, but if I remember correctly, you can recursively challenge you can dispute multiple times, right? Like you can dispute the results of a dispute.
Yes. So this was the reason that you need this is more so for like flash attacks. um, at the end of each sort of round, what happens is, um, let's say you have a 2-day long vote period and only only 2% of your token votes on it because it's an on-chain vote. Nobody really cares. It was obviously a bad value. The team voted it was a bad value, and he's going to get slashed. Well, what happens if at the last minute or the last block, then somebody comes in with a really big TRB balance and throws the vote the wrong way? They say, no, he shouldn't be slashed. He should get to keep his money, and the disputer should lose his fee. That would be a bad attack. So the way that you fix it is you say, after the vote closes, anybody can reopen the dispute for a day. So you can reopen it again. And what would happen if you reopen it again? Now the fee doubles, and hopefully more people, you can go drum up some more support. More people can vote on it, and you can say, all right, they're obviously doing this to the protocol. Please go and actually vote this time versus just relying on the team. And when you have this multiple rounds, what happens is because ideally you want it to the point that you have a dispute, one person votes on the dispute, and it's a valid vote. They voted the correct way, and then nobody else has to waste gas to vote on chain because it's very inefficient to vote on gas on chain. So making it that, listen, just don't be a dick to the rest of us and make us waste our time. Just let us go with this result, get some people their money where it goes, and that's sort of where the game theory would fall.
Yeah, I mean that's great. So in that way, you don't you have this system sort of that's capable of recursive challenges to bad values. And so the game theory there is the person that is most invested in TRB wins that. And kind of similar to the guarantees of proof of stake, it's just it's proof of stake with extra steps in a good way. So you've got like the same guarantee that proof of stake has, that the investors are going to vote the right way, the way that's going to accrue the most value to them. You have that, in the very worst case scenario in Tellor, the voters, the holders of TRB, are going to vote to slash the misbehaving nodes.
Yeah, no, I mean, that's where it makes sense. It could go in the big difference, I guess, is that we're a smart contract and they're an L1. So they have an ultimate backstop.
Right. True. I mean, there's plus is the social layer that ultimate backstop that you're thinking of?
Completely. Yeah. I mean,
Right.
that's, ultimately they can fork and smart contracts can't.
Right.
Which gets, yeah. So that's, yeah, not that happens all too often, but that's for maybe a different discussion.
Well, potentially later discussion, on the topic of L1s. But I have a
Right.
couple other questions. So maybe you can talk a little bit about how Tellor has evolved over the years. Like I'm curious and interested in what V1 was like, and how you changed that for V2, and maybe why. Like, can you give us some insight into your design process and how you upgraded from V1 to V2 and what caused that?
Yeah, I mean, so the first one we did was a proof of work oracle. Um, and the way that it would work was you would basically have to mine of this was similar to like um, it was basically almost identical to Ethereum proof of work. We had a custom algorithm, and you would mine the solution, and then you could report a value with it. So you'd have a small stake, and then you'd have to solve proof of work and submit it. And that was like we thought that would be a cool proof of work oracle. And it was super fun. We started in a completely. This was back in 2019, and we had a fair launch. So this was most people nowadays don't even know this term, but it was you started with a zero supply and you just went forward. So a fair launch would be like the Bitcoin model. So you don't start with a supply, you just start minting from day one as a block reward, going out to people. Um, and I even forget what the block reward was at the time. It was a lot. Um, we were minting like it was something like 5 TRB every block or something like that. It was a whole lot. And back then, we did this. We had like one investor, which was Binance. We were part of Binance Labs, and they gave us a small amount of money, but we didn't really have any backing, so we couldn't even really get people to partake in the protocol. They would be like, "Listen, man, I'm spending $20 a day on gas on Ethereum," which was that was a lot back then, and then they would say like, and like all I'm getting is like they would get like 1,000 TRB tokens in a day, and they're like, "This is totally not worth it," like because they couldn't sell it anywhere. We didn't have any exchange listings, um, and so people wouldn't do it. But then what happened is we got sort of popular amongst the proof of work coins. Um, we people started building like FPGA chips. It was like from the time we launched, it was like 2 months later I built a GPU miner, and then like 2 months after I built the GPU miner, then somebody built like an FPGA chip, and they were selling these FPGA chips for like 10 grand online from these like Chinese websites where you could go and like mine TRB. I think it was like TRB slash Raven coin miners. Um, and so like our entire mining was all the reporters from what used to be, like GPUs and people just running in. It was like a cool little community. Then it quickly turned into like Chinese FPGA farms. This was like within 6 months. It was like crazy. And so we figured like, okay, this isn't quite the decentralized protocol that we wanted it to be. um, and also like whenever you do, we wanted to change the tokenomics a bit. So we liked the idea of like the fair launch and starting with the zero supply because the distribution's really awesome in the sense that anybody can come on, and you're basically wasting electricity to mint tokens. Um, and you don't really have any allocation. But now that it was going all towards Chinese FPGA farms of people, and we already had some supply out there, it was like, okay, well, how can we get on exchanges and have an inflation rate that isn't 100% in the first year, or in the second year it would be 100%. And so we're like, okay, so we need to drastically cut inflation, and we wanted to move. We then realized that we probably need to move to like a proof of stake model, which is actually where most of the security was anyway. Because if you think about like the Bitcoin, if you look at any of the proof of work coins, the cost of 51% attack is relatively low. Like I was just looking, like Bitcoin Cash is like $7,000 to attack for an hour, and that's fine for proof of work networks that have like a social layer, like like just use it slowly, and you have a social layer that you can fall back upon. But whenever you're a smart contract, and hopefully these people using your Oracle, they want some fast finality on this stuff. Obviously, we still had the disputes and things like that, but it was like you could easily censor the network really, really fast for a long time, and it just wasn't as secure due to the centralization and proof of work. So we're like, okay, we need to switch over to the proof of stake model that we currently have, lower the inflation, and that's kind of how we moved over. So hope that was like a quick explanation.
Yeah, definitely. I mean, that's really interesting. So you guys were actually one of the OG proof of work coins, like the 2019. That was actually probably like probably one of the last proof of work coins, because I can't think of anybody else that's launched since then that's been proof of work.
Yeah, I don't know. I mean, it was popular back then. There were a lot of coins still launching with proof of work stuff.
Right.
Well, because Ethereum was still proof of work. So like, believe it or not, this is another thing that sounds so foreign saying, but it's like, back then, like it was like, how can you entice the mining community to come interact with your coin? And that was a big deal. If you could get, all the GPU miners or all the Bitcoin miners to talk about your coin, that was how you got exchange listings and things. But yeah, now it's just completely gone.
Yeah, I mean, I remember whattomine.com or whatever that was,
sure.
where it was like you could see like, oh wow, like Grin has 6,000% APY right now. We should mine that. And yeah, that was a trip. There was a whole ecosystem of people just like looking for the absolute best returns at the moment, with GPU miners that could just switch over from one algorithm to another.
Yeah, and I mean, it was cool. Like that was actually like our whole community for the first year were those proof of work people, and it's a great community because like the mining community tends to be more blue collar in some ways. Like it's people who actually own these, GPUs, and they're on this thing and grinding out in the command line. So it was like it's not like this is Stanford dev crowd, if you will. It was these, guys who were just trying to make $5 a day mining some shitcoin, and it was yeah, but it was it was a really cool community, so we were happy to kind of have them.
Yeah, and I mean, I think probably that early proof of work community really informed and aligned with Tellor's ethos of censorship resistance, because proof of work people are on the whole much more focused on censorship resistance, and I guess anybody that's interested in crypto consensus algorithms is going to be more aligned with censorship resistance. But people that are mining and understand proof of work, I would say, tend to skew more heavily censorship resistance focused.
For sure. Yeah. Just an easier narrative in a lot of ways. Say, but
Definitely. Yeah. So, okay. So you guys moved basically from V1 as a proof of work, proof of work consensus mechanism, or Oracle providing mechanism, to proof of stake. And what have been like the differences that you've seen? Like how has that panned out?
yeah, I mean it's been good. We secure some protocols now, and people can come on and obviously use this. It's a little bit more straightforward for people who are, proof of work is kind of scary now. So people understand it's a nice simple model. People understand how it works, how it's crypto economically secure, and and we've just kind of been going at it. It's been good as far as you can deploy it on other networks. It's a system that you can copy easily. Um, yeah, no complaints with kind of how it's working, but I think this is how you go into, like, we are making plans for the next version, obviously, uh, which
Yeah.
is another thing. Um,
Yeah, that was kind of where I was going with
yeah,
this. What I guess what downsides have you seen either from the upgrade or with this latest version, and how are you thinking about those going into the future? Like you guys are
yeah.
moving toward. Yep, go ahead.
So I mean, the biggest problem right now, well, there's like two problems. It's A, how can you get faster for users? And we've noticed there's just been such a demand for speed. Like, we're optimistic, so we tell people, oh, just wait 15 minutes before you read a price, and they're like, no, that's just unacceptable. And you're like, listen, man, security is not unacceptable, but it's like, we want to see how can we get faster and stay crypto economically secure. And the other piece too is that when we built Tellor, this version in 2020, everything was on Ethereum. There were talks of L2s at the time, but there was nothing anywhere else. And now we found ourselves, so we can deploy our system on other chains. So we're on Polygon, we're on Optimism, Arbitrum, Gnosis chain. We can deploy. It's just a smart contract system. We can deploy it over there. The problem is that you have to bridge the Tellor token over to use it. So the problem with doing that is it works for, say, 3 or 4 networks, but let's say you have 1,000 app chains. Are you going to bridge Tellor tokens over to each one? Maybe, and you could, but now it's like there's sort of this parasitic effect as far as, like, the more chains that you have, now the validators have to decide which chain they're going to be running on, and it can get more expensive for users to have to pay them because it's not all on one network, and it's not easy because you have to sort of entice validators paying them versus validating or reporting on other networks, which is a problem. So that said, how can we sort of get the validators all in some place? And this is where we came to the, what we've seen is this giant trend over the last few years of solving bridging. I know this may come as a surprise to some people listening, but bridging data is it's just about solved. Like right now we have still, like, bridges look a whole lot like oracles in the sense that they're mainly just multi-sigs. And the reason is that it's really fast if you just use multi-sig. But that doesn't mean you don't have things like trustless bridges. Namely, these are light client bridges. So like a light client bridge, we've known about these for a long time. You actually just validate the consensus of the other chain. So like for like Cosmos, which is easy, you have a set number of validators, and you need 2/3 signatures of the validators to move forward on the block. So like what a light client on Ethereum would look like for a Cosmos chain would be like, you just get you have a validator set, and you get 2/3 of those guys to sign off on some piece of data, and that's consensus. That's just how it works. And what's even cooler now is, obviously, the problem with doing that first light client is that you have to like loop through all those signatures, which can sort of be very, very time consuming and very expensive in gas. But now people are creating like zero knowledge light client bridges. So we're working with a project called Succinct, working with Mina, doing similar stuff. How can you validate Oracle data from one chain on another chain? And that's, how can you do it in a zero knowledge proof? How can you do it with a light client in that it's completely trustless? So you're trusting that the validators of the Oracle data were the ones that signed off on this, and there's sort of no need to trust a third-party intermediary to bridge over the data, and you can do it fast. And that's kind of the problem we're working on solving now, and that we're building towards launching next year.
That's awesome. So you guys are doing basically an app chain, and you're going to be focused on bridging data across chains and validating other chains' consensus.
Well, other chains are gonna validate our consensus to bring the Oracle data over. That's
Oh, okay. Got it.
yeah,
So you're facilitating like that their ability to validate yours rather than facilitating all of the other chains' ability to validate each other's consensus.
right. Yeah, so that way they can read Oracle data for that. So we come to consensus on data. So our chain is going to be a Cosmos chain. It's going to be very, very similar to Tellor data, or the way that Tellor currently works, except that what you're going to do is you're going to stake to become a reporter slash validator, and then you're going to sign off on data. But since it's a really, really cheap chain and you don't have to worry about gas prices, you can have everybody sign off on every piece of data, which is something that's just astronomically too expensive on Ethereum. So you can just have, if you have 100 validators slash reporters, you can have all of them sign off on an ETH US dollar price. And now the amount of stake behind that is way, way higher. You basically just came to consensus on it, and protocols can use it right away. It's much faster, and that's what we're hoping that people do.
Awesome. So I guess you would have the data providers on the Tellor chain be crypto economically incentivized, and then you would have that additional set of validators that's signing off on any of the data that's there.
Yeah, so I mean, you would be validating the chain, and then you would also be reporting for prices, and it's different than like just having like the validators sign off on prices, and they have to, like, everything's still optional. Like that's one thing that we like about Tellor versus other protocols, is that you don't have to sign off on data because you can get disputed for it. So like if like, let's say if you want to make it trustless, like anybody should be able to request anything. So say you want to request the price of some very, very small token. Well, not all validators might support this. All reporters aren't, they don't want to go set up a new API and report this data. It might be too much work for them, but maybe some of them will. And so some of those people have the option to go report it. You can see how much of the stake has reported on your value, and you can decide how optimistic or not optimistic you want to make it. In the same sense, ETH US dollar, Bitcoin US dollar, cross-chain, Ethereum calls, things like that, almost everybody should support right out of the box, and you can come to consensus right away. So it'll be a little bit better and faster.
Okay, so just to clarify my own understanding of this, you've got data providers who can provide whatever piece of data they want to on the chain, and then you've got these 67 of 100 validators that are validating that not necessarily that the prices that the data providers or the information that the data providers are giving is accurate, but they're just saying, here's, this is the data that exists on the Tellor chain.
Correct. So
awesome. Yeah, I mean, that's like two layers of, it's cool because I would imagine you're using some of the same mechanisms in your 67 of 100 consensus as you are, in the Tellor protocol.
Yep, it's the exact same. The same recursive dispute models, same sort of trustless data as far as anybody can request any sort of data, anybody can report on any data. Those are things that we're excited to bring over that other protocols don't have. So
that's really awesome. And so that's gonna make it so that you can provide data faster to the protocols that need it through a light client bridge to other chains.
Correct. Yeah,
really
and
cool.
And right now we're keeping the tokenomics the same as on current Tellor, but if you have any of those amazing ideas, we'd love to hear them at the community.
Yeah, I mean, I would love to talk more. I think I was preparing to send you a message after this to suggest maybe some changes to make it even more efficient, less capitally intense, and faster time to finality. So we can chat about that. But we're coming up on the hour, so maybe I'll open this up. Does anybody from the audience have a question for Nick that they'd like to ask? If you do, just request to speak. I'll bring you up here, and then we'll sort of wrap things up. I've got a hard stop at 2. 1, I guess, your time. Right, I'm not seeing anything from the audience. So if you guys do have a question, just request the mic and I'll bring you up here. But if not, Nick, what else would you like to share with the audience? Where can they find more information about integrating Tellor, and where do you want to point them?
Yeah, I mean, our website's always good. Tellor.io, docs at docs.tellor.io. yeah, definitely just come follow what we're building. You know, we're really active. We're on as hopefully you can tell from this conversation. You know, we're trying to build the best Oracle that we can, trying to build the best Oracle for the future. So if you have any ideas or any criticisms, you know, we would definitely love to hear them.
Awesome. Well, yeah, this has been great. Thanks for sharing all of this information on Tellor. I'm really excited for the app chain that you guys are building and the potential implications of having that really fast data, fast to finality integrated in protocols, because censorship resistance is the reason that this space thrives and is the only unique value proposition of blockchains that can't be replicated with existing technologies. So I'm really excited that you guys are focused on solving the problems you are, and very grateful that you would join me today on this inaugural protocol spotlight space for Token Dynamics.
Yeah, this was fun. No, I'm definitely coming on the other ones and asking hard questions for guys. So this was fun.
Yeah, definitely. I want to have you on one of the tokenomics AMAs at some point, because the conversations that we have like off the offline have been some of the best conversations that I've had with anyone in the space.
Oh, cool. Yeah, no, well, thanks for having me. It was fun.
Thanks for joining, Nick. It was really a pleasure. And thank you to the audience for coming on and listening in to Tellor talk about their protocol and their upcoming app chain. So look out for more information on that. Go follow them. They're We Are Tellor, and follow Nick, the Fett, and tune in for more of these spaces. Looking forward to seeing everyone in here in the next couple of weeks as we bring on more guests. Thank you guys. Wrapping up. Catch you all later.